that long. Our AP exam's always been on Wednesday, and now it's on Thursday. So, kind of grumpy about it. It's always been my exam, and English has to be, and now it's English, and then you guys are all going to be day before. I agree well. I don't like that. So, that's right. We'll just meet right early on the day of the exam. That's a good thing. Volume. Maybe we're just going to practice the whole part. So find the area of the regions enclosed by the lines and the curves. When you look at this problem, you could just start graphing it, but by looking at the equations, do you think we're going to use y bounds or do you think we're going to use x bounds? Y bounds, because the y is squared, like think about if you tried to get y by itself, you would get plus or minus the square root, which means you'd have two functions there, which would be a really big pain to integrate all of that. So when I see this, the first thing that I'm going to do is I'm going to solve it for x. Okay, so this would be x equals y squared. And this one would be x equals minus negative 2y squared plus 3, or 3 minus 2y squared. And we could graph this, and we can graph this if you want. But I also want to remind you that you don't have to graph it to find your bounds. You don't have to graph it to find which one to put it first. So remember, what do we do if we don't want to graph it to find our bounds? Set them equal to each other. So I could say y squared equals negative 2y squared plus 3. Add that over. That would be 3y squared equals 3. So I know my integral will have bound 1. And also I know that people struggle more graphing in terms of what is x equals. To make an xy chart, we could graph this. But again, if you want to just figure out which one is bigger, which one is more to the right, I think this will work. We could just plug in like 0 and see which one gives us the bigger number. Will that work? If we plug in 0 for y, we get 0 for x. If we plug in 0 on that one, we get the 3. So I think we should take this one then. I've always, yeah, I've distracted. But I feel like people get bogged down by the graph sometimes. So but it should make sense to you that this would be a parabola starting at 0 going like this. And this one is moved over, like when you put in 0, you get 3. So it's 3, 0, and it's negative, so it's going to be going back. We're not actually graphing it accurately. Like, that's what that sort of should look like, which is why this one should be the right function, and that one should be the left function. And again, I just think it's a really good idea to know that you don't have to graph it. And now it's just a practice of integrating, because I feel like this is something I'm supposed to do. So easy to make a negative mistake. Square the AP exam knows also the questions. That's why I kind of make you do this without a calculator in this chapter, and then sometimes you use a calculator, but you just want that practice of the arithmetic here. So this would be negative 1 plus 3 minus, if I plug negative 1 in there, that would be positive 1 minus 3. Look, that's what I do. I did this right, and then I added wrong. Like, I was like, oh, my ones cancel out. That could definitely be a problem on a no calculator part. Multiple choice. Big deal. It works out really nicely. Oh, what if I gave you this one? I don't know that it is like calculator. But notice that we're only graphing from pi 6 to 5 pi 6, right? Which means that we could graph the whole thing. We could also just plug in pi 6 and 5 pi 6 and kind of see what's happening there. Cosine should be easy to graph. I hope. I hope that cosine is kind of in your brain where you remember it starts up and it goes down and it kind of makes that lovely graph there. Right? So, kind of a quick review of graphing. Right? So here's 2 pi, you can kind of let everything happen again. We go up to 1, and then it goes to 0, it goes to -1, back to 0, back to -1. We only want it from pi 6 to 5 pi 6, which means pi 6, what is it? Because it's 1/2, square root of 3 over 2. And 5 pi 6 is not even a pi, right? 5 pi 6 is 1 pi. What is this 2 in front of the x means happening this time? We're changing it. Go on, follow it up for people. What is this? What is the 2 in front of this means happening? Our next unit test after the conference. Next week, Monday, we're taking a test. But what's happening? What's changing? The amplitude's changing, the period's changing. Amplitude's out front. The period's changing, right? So normally the period is 2 pi. This one would be 2 pi over 2, which means the period is just pi. So that means between 0 and pi, we're going to get that normal sine graph, just one hump up, one hump down. So if we wanted to do that, maybe you should all these ones. Okay. Sine starts at 0, goes up to 1, down to 0, down to -1. This is flat. That's a really bad graph. I think the only place they overlap is at the I think we have this little section here, and we have this little section here. You should graph on your calculator and give me a deal. Bounds to 556 to 556. So there's K down beta. These spots that you take, I would believe. my window I'm going to change to 5, 6, 5, 5, 6. And I'm going to change my scale to 5, 6 as well. So, starting at 5, 6. Do I just say 5, 6 to 5, 5, 6? Which function is on top of it? The new one, right? The fine graph. That's just going to give me the area of that little section there. And then we could add the other one. This is going to be different valve. Do we need to add this yet? Or can we do something else? Well, because it says find the area between the curves, we're not really like not making that makes sense. There's symmetric areas there, so yeah, I would double that. Like if I ever notice I have symmetric parts of my graph, I could just find the 1 and double it. You're talking about like full movement of the graph. So like how far did it move? You're right, you try to say that it would be 0 here, but it and because the question just says find the area between the curves, we're going to have line from the actual outside and convex. Yeah, that's kind of like some substitution there, right? Oh. I'm going to put my 2 up here. You need to do substitution on that, or can you do it without you? What would you do? It would be 2x. So du equals 2dx. Right? Like we need to take care of the fact that a chain rule, it would have a 2 there. So we have to divide that over, and we really need a 1/2, right? 1/2 du would equal to dx. For me, when there's just a number in front of the trig like that, I don't usually do U substitution. I just say, oh, I either want half to fix that, and the integral of sine, isn't that negative cosine? Negative cosine of, you always check by taking the derivative of that and making sure that it equals sine, but you have to kind of counteract the two. Minus the integral of cosine is just sine from pi 6 to pi half. And then don't forget that we're doubling it because we're just doing 1. I will tell you the last 3 years, they switched 3 years ago from 3 no calculator, 1 or 3 response and 3 calculator. Now they do 2 calculator and 4 no calculator. And every year since they switched that, there's been 1 no calculator 3 response. That's pretty heavy on basic trades, like universal trades. It makes me super happy to see that because to me it's like a not bad one. You have to be able to do some trick stuff without calculator. No values. So I'm just going to here for now. I'm going to say that's negative 1 half cosine of, when I plug pi halves in there, I actually get pi minus sine of pi halves minus, I'm going to try to distribute my figures, so that's going to become plus 1 half cosine of 2 times pi 6 is pi thirds, and that's going to become plus sine of pi 6. Talking about free response, not having to simplify, this would get you no credit, right? You have to be able to take the value of those trig functions. Then you can leave it all as numbers, because that does not count as just numbers, right? Those are still trig functions. So cosine of pi is negative 1 times negative 1 half. 1 half sine of pi halves is minus 1. Pi thirds, cosine of pi thirds is 1 half, right? So that's 1/4. And sine of pi 6 so that's 1 minus 1 plus 1/4. So I think you just get 2 times 1/4, which is because it's 1 half plus 1 half, 1 minus 1 gives me 0 plus 1/4. I've done this before, and I left that 2 off, and then I said my answer was 1/4, and I forgot that I was doubling it. So really fun. Do that and keep that 2 out front the whole time. Love that. I still have a major assignment. You could do this by hand, but let's practice on our calculator. So if you have a calculator, you should graph this and see if you can figure out where they intersect. I'm just going to zoom in. Maybe wait for these ones. And again, this is what I mean by the part that sometimes you get to the graphic calculator takes longer. You're going to see as you look at these graphic exams that the calculator part of the test is more basic questions, and the calculator part of the test is more application questions. Oh look, I found the guy. This is like, okay, I have my intersection. Oh, they definitely are even and it's not just that they look even. Remember that cosine is even and a quadratic is even. So definitely we could just do one side and double it like we did on the last one. That's going to happen a lot. The red one that was on top, right? And so we could find this intersection point again by doing second calc over 5 intersects. And again, if you have only 2 graphs done and you just hit enter, it will always keep it. Also, you can scroll to find your intersection point. You can also just type in a number if you want to guess what the intersection point is. So, I could say, here is the intersection point. Here's that. So that was at 0 to 1. You can actually check in that graph. It does work if you plug in 0 to 1. And this is where quadratic is, right? The red graph was the quadratic graph. It was on top. So 1 minus x squared minus cosine of pi x over 2. And since we use our calculator to graph it, we can just use it. Right? And there's definitely questions. I really, as we start practicing this exam, if you're allowed to use a calculator, you shouldn't be integrating by hand, right? Because you're just going to plug that in. So that's 9. This is where if you're in degree mode, you will get a not a good answer because you can't be in degree mode on tree function. So you get 0.0300, like if you were going to 3 decimal places, like that would be your 3 decimal places. But don't forget that that was only this little section. So I forgot that. I would have missed that because I guarantee that would have been a choice. If you double it, then that's like 0.06. You could also have integrated this by hand. I just thought since we graphed it on the calculator, I want to integrate it on the calculator. Think about if you were going to integrate this. If you were going to integrate this, again, you'd have to use a U substitution. You'd have a 2 over pi out there. Just to let you know, I integrated it by hand on my notes over here. And I got an answer of 4/3 minus 4 over pi. It's the exact same decimal. Looking at that. integration plan. So, I just have some more questions today for you on the homework. Again, some of them are easier than others. I'll tell you 7 and 8, the directions say use the calculator to find the area. There's things you can calculator to find your bounds and then integrate on your calculator. But then I believe the rest of them, you should be trying to do those analytically. With your calculator you can, but you should be trying to do those analytically. There's one with and definitely think about, should I be integrating with respect to X or respect to Y on some of these, because we don't tell you what to do. And then we'll talk about what questions we have tomorrow. And I haven't decided yet tomorrow if we're having a worksheet or a movie on, but definitely the